All right, so on Tuesday, we briefly introduced inverses on a table or a graph, okay? And all you need to do was switch the x and the y, right? So now we're gonna talk about it from an equation, okay? But you're still doing that same thing. You're still switching the x and the y, okay? So these are the steps, okay? Since we're gonna switch the x and the y, I would always replace f of x with y. Sometimes it'll already be y, sometimes it could be g of x, but always make it a y so that you can focus on switching the x and the y. Once you've switched your x and your y, then you're gonna solve to get y by itself again. Okay, so if we're looking at this first example right here, we have f of x equals, well, you know this is really y, so we have y equals 2x plus 3. Notice y is by itself here. Okay, but if you switch the x and the y, your y is now going to be over here. So step 3, you would need to solve for y, so get y by itself again. Okay, those are your first 3 steps. Okay, so let's go through this first example. So we've done step 1. I replaced f of x with y. Step 2 is to switch the x and the y. So they're going to switch places, right? My equal sign stays where it is, my 2 stays where it is, my plus 3 stays where it is, but the x and the y are going to switch places, okay? So I'm going to have x equals 2y plus 3. That's step 2. Step 3, solve for y. So just like we would solve for x, you're now solving for y. So we want to get y by itself. So when we're trying to get a variable by itself, you always want to cancel out whatever's added or subtracted to that variable first. So the opposite of adding 3 would be to subtract 3. Whatever you do to one side, you've got to do to the other side. 3 minus 3 is 0. So on this left side, x minus a 3. These are not like terms. I cannot combine them, so this just stays as x minus 3. And we bring down our equals to y. Now we have 2 times y, so to get y by itself, we cancel out the 2 that's being multiplied by doing the opposite and dividing. Okay, 2 divided by 2 is 1, so we have 1y equals, we have x minus 3 divided by 2. Okay, this is your answer. Some other ways you could see this written is if they actually split this up, because we have x minus 3 divided by 2. Well, it's the same thing as saying x divided by 2 minus 3 divided by 2 equals y. That's also the same thing. Or making this, because you have a 1 in front of your x, right? Writing this as a 1/2 x minus 3/2 equals y. All 3 things mean the exact same thing. You could see it usually written one of these 2 ways. This means the same, but usually it'll be written one of these 2 ways, okay? Or you can always move your y to the other side, and it means the same. So you could say y equals this instead of writing it. That still means the same thing, okay? Example 2, find the inverse function of f of x equals a negative 4/5 x, okay? So, step 1, replace f of x with a y. Step 2, we're going to switch the x and the y. They're going to switch places. So we're going to put x equals a negative 4/5 y. And step 3 is to solve for y, okay? So, to cancel out a negative 4/5 that's being multiplied, we really want this to go to 1, right? So what we're going to do, to cancel out a dividing by 5, we multiply by 5, right? And we would do that to this side. I'll put it over here, times 5. And then to cancel out a multiplying by negative 4, you do the opposite and you divide by negative 4. Okay? So basically you just multiply by this fraction flipped, right? Oops. Make it focus again. Okay. So by doing that, 5 divided by 5 is 1, negative 4 divided by negative 4 is 1, leaving us with that 1y. And then, sorry, my elbow's squeaking. So then we do negative 5/4 times x, and you get a negative 5/4 x. Y is by itself, so this would be my answer. Or you could see it written with that inverse, the f to the negative 1 power of x equals a negative 5/4 x. One way we could check our answer is pick any number to let x be. Okay, so let's say we chose 0. Okay, so if I choose 0 to plug in for x, I would put a 0 here. So I'd have 2 times 0, which is 0, plus 3. So 0 plus 3 is 3, so my y value is 3. Well, for the inverse function, we should be able to flip this and have 3 as my x and get 0 as my y. So let's go down here. It doesn't matter which one you choose. This is probably the easiest form to plug into. So we would plug in a 3 for my x, and we would have 3 minus 3. 3 minus 3, which is 0. And 0 divided by 2 equals 0. Okay, so you can see it works. You flip the point, you plug it into the inverse function, and it gives us our other value. If I were to check my answer for this one, let's say I chose x to be 1. Okay, so I go up here, and I plug in a 1 where x is. 1 times a negative 4/5 is a negative 4/5. Okay, so if I flip that, and I have my x is now negative 4/5, I want to see that my y would become 1 when I plug my x in. Okay, so for this, we would have negative 5/4, and instead of x, I'm plugging in a negative 4/5. Well, you know a negative times a negative makes a positive. 5 divided by 5 is 1. And 4 divided by 4 is 1. So you get negative 5/4 times the negative 4/5 is 1. So we got the same thing, just in reverse. Is by graphing it to determine whether they are actually inverse functions or not, to see whether we did it correctly. So I'm going to graph these. My original equation was y equals, I want the top part to stay on top. If I typed 6x plus 2 and then hit divided by 3, the only thing that got divided by 3 was the 2. That's not what I want. So to keep the whole 6x plus 2 on top, I'm going to put it in parentheses, and then I'm going to divide by 3. So now I have 6x plus 2 divided by 3 all on top of my equation. Here it is graphed. Then I'm going to type in my inverse, so we had y equals, we can do a 1/2, and then I'm going to put my, sorry, I'm not good at this. Then I'm going to put my arrow to the right so it comes to the side of 1/2, and then I'm going to put x. Then I'm going to put minus 1/3. Okay, so now you can see that function. We said, or you saw in one of those videos, that these two should be reflections of each other. If we turn it 45 degrees, they should reflect. So the equation that would show reflection, or the line that they need to reflect over, is the parent linear function, y equals x. And you can see that that function is in green. If I turn it to the side, you can see that the red and blue functions are reflections of each other across that green line. Y equals x. All right, example 4, okay? Sorry about this coffee stain on the paper. It's just gonna be there. All right, so find the inverse of f of x equals negative 4x minus 5. So what we're gonna do is start by replacing f of x with y. Okay. Step 2, switch the x and the y. So we're going to have x equals a negative 4y minus 5. And we're going to solve for y. So I'd add 5 to both sides. These are not like terms, so this just stays x plus 5. Divide both sides by negative 4. And we get y equals, we're going to put that negative out front, x plus 5 divided by 4. This is one way you could see your answer written. Another way would be if we split it up. So I'm going to divide this. So I'd have y equals a negative, the number in front of that x is a 1, so negative 1/4 x. And then I'm also going to divide the second term up top. I'm going to have plus 5/4. If we went to Desmos.com and I typed in my original function, I typed in the inverse function, so my original's in red, inverse function's in blue, and then I did y equals x, which is that line that they should reflect across, and I looked at it over here, turned it to the side, you can see that the red and the blue are reflections of each other. If I were to take this red line and reflect it across to the other side, it would reflect across this blue line, right? Same thing here. If I took this blue line and I were to reflect it across the green, you would get this half of the red line here. Okay, example 5, find the inverse function of g of x equals 8 plus 1/4 x. G of x, same thing as y, okay? So step 1, switch our x and our y, so we get x equals 8 plus 1/4 y. And then we're gonna solve for y, okay? So I'm gonna subtract 8 from both sides. I have x minus 8 equals a 1/4 y. All right, so to get y by itself, I need to cancel out this 1/4 that's being multiplied by our y. So to cancel out a 4 that's being divided, I'm gonna multiply by 4. This 1 is being multiplied. I want my y to stay as a 1y, so you don't have to. If you want to divide by 1, you can, but that changes nothing, right? And we're going to divide this side by 4. Multiply this side by 4, sorry. If you want to divide by 1, you can. So 4 divided by 4 is 1. 1 divided by 1 is 1, so we're left with 1y equals, you can leave this as a 4 times x minus 8, that's perfectly fine. This is one way you could see your answers written. Another way you could do it is to actually distribute that 4. So we would have y equals 4 times x is 4x, and 4 times a negative 8 would be a negative 32. This is also another way you could see it written. Either one of these ways is perfectly fine, or once again, if you replaced y with an f to the negative 1 of x, that's perfectly fine too. They mean the same thing. This just shows that it's the inverse function, right? All right, and last one, I've just been going through a ton of different ways that you could see these equations written so that you know how to solve the different types, okay? So I kind of forgot the f of x when I wrote this. I got ahead of myself just writing out the equation I want y'all to solve. So this says f of x equals 1 minus 2x divided by 3. We want to find the inverse of the function, okay? So f of x is really just y, and we're going to switch our x and our y. So x equals a 1 minus 2y divided by 3. So to get y by itself, we're going to start by canceling out this 3 that's being divided by doing the opposite and multiplying by 3. So we get 3x equals 1 minus 2y, because 3 divided by 3 is 1, so those go away. And then we're going to cancel out the number that's added or subtracted to my 2y. Subtract 1 from both sides. 1 minus 1 is 0. Once again, these are not like terms. Do not combine these. 3x minus 1 is not 2x. This one has an x, this one does not. So it stays as 3x minus 1 equals, this negative stays with the 2y. So this is a negative 2y. Then to get y by itself, it's being multiplied by a negative 2, so we're going to divide by a negative 2 on both sides. So we get y equals, I'm just going to put the negative out front. We have a negative 3x minus 1 divided by 2. Perfectly acceptable way to write your answer. You could also write it with the inverse function, right? And you could divide this. So a negative 3x divided by 2 be negative 3/2 x. And then we would have a minus 1/2. Another perfectly acceptable way to write that answer. You can always check it by going to Desmos.com and typing in this function as well as one of these functions along with the reflection line, which is y equals x.